Hey, hi, and welcome back. So now you have a good understanding of Atmega 328 microcontroller, and now it's time to understand the minimum components that we need to connect around the microcontroller in order to make it work. Okay, so in part 1 and part 2 of this video series, we are going to discuss the same thing. We will see what are the minimum components that we need to connect around the microcontroller in order to make it work. Alright. So now let's start with this video, which is about understanding circuit of microcontroller part 1. So this is basically the circuitry of Atmega 328 microcontroller, and you can see around this controller there are actually very few components connected, and in this part 1 we are just going to discuss this part, which is VCC and AVCC part. And along with that, we will see the different capacitors which are connected here. So we will try to understand the purpose of these capacitors, and also we will try to understand this reset circuitry. So this part and this part we are going to cover in this video, and in next video, which is part 2, there we will see this debug/programming header and their connections. Along with that, we will see this crystal section. Okay. So now let's start with these VCC and AVCC pins. So we have already discussed that VCC pin is actually responsible for powering the digital interfaces which are present inside the microcontroller, and this AVCC pin is actually responsible for providing the power to the analog interfaces which are present inside the microcontroller. Okay, and we discussed that ADC is basically one of the peripheral which is there inside the microcontroller, and to this particular peripheral is actually powered by this particular pin, which is AVCC. Okay, and as per the data sheet, we need to connect these two pins to the plus 5 volt. We saw that we can also connect these pins to 3.3 volt, but in our case, as we have generated plus 5 volt with the help of 7805 IC, so we are going to provide plus 5 volt to these two pins. Okay, and if you observe the VCC pin, you will find that here 4 cross 2 is written. So what exactly that means? Let's try to understand that now. We saw that there are actually 2 VCC pins in the Atmega 328 microcontroller. So this 2 actually represents the 2 pins. Okay, and this 4 actually represents the first VCC pin. Okay, so pin number 4 is actually the VCC pin on this microcontroller. Now you will have a question that where is the number of second pin? So the number of second pin is actually not given here. And this is actually the way we represent the symbol of the microcontroller. For example, if you are dealing with an IC, let's say you are dealing with the microcontroller, and in that particular microcontroller, there are total 6 VCC pins. Then in the symbol of that particular microcontroller, only the pin number of the first pin will be given. For example, let's say that pin number 2 is the first VCC pin, and after that asterisk sign will be there, and then 6 will be there. So this actually represents that there are total 6 pins, 6 VCC pins in the microcontroller, and 2 represents the first VCC pin of that microcontroller. Okay, so remember, this is actually the way we represent VCC pins in the symbol of microcontroller. Okay, and this VCC pin and AVCC pin, as we discussed, these pins need to be connected to plus 5 volt. Alright. And here you can see this ground pin is actually connected to the ground. So this single pin actually represents the 3 ground which are present, 3 ground pins which are actually present on this microcontroller. Okay. So you can see here 3 cross 3 is written. So 3 represents the number of ground pins on this controller, and this 3 represents that pin number 3 is actually the ground pin on this microcontroller. Okay, so if you connect this particular pin to the ground, then all the 3 ground pins will be connected to the ground. Okay, in the same way, if you connect this VCC pin to plus 5 volt, then all the VCC pins will be connected to the plus 5 volt. Okay, after that, now let's try to understand the purpose of all these capacitors that we have connected here. So let's start with this capacitor, which is C11, and the value of this particular capacitor is 22 microfarad. Okay, so let's try to understand the purpose of this particular capacitor. So we have connected this capacitor on the VCC line. The reason is, whenever there will be a sudden current requirement by this particular microcontroller, that current requirement will be actually fulfilled by this capacitor. So the current will be actually, the IC is actually going to drain the current directly from this capacitor instead of taking the current from the 7805 IC, because there will be a long track from this VCC pin towards the 7805 IC. And generally, the microcontroller actually needs current very fast. And if that current requirement is not fulfilled, then what will happen, the voltage at this point, it will actually drop. Okay. And that's the reason we need to connect a capacitor here with a value of 22 microfarad or somewhere around that. And this capacitor will be responsible for fulfilling the current requirement of the microcontroller. Okay. Now here you will have a question why you have selected the value of 22 microfarad here. Now, you will actually get this particular value or value near to this value in the data sheet. So in the data sheet, it will be given what will be the value of bulk capacitor. So this is actually a bulk capacitor. The reason why it is called as bulk capacitor, it's because this capacitor is actually responsible for fulfilling the sudden current requirement of this microcontroller. Okay, that's the reason it is called as bulk capacitor. Now let's come back to the point why the value of this capacitor is 22 microfarad. So you will get the value 22 microfarad in the data sheet, and in the data sheet it will be given that you need to connect this particular capacitor near the VCC pin in order to fulfill the sudden current requirement. But generally what I have seen, for example, if the controller is draining a current up to 250 milliamperes or 200 milliamperes or 300 milliamperes, somewhere around that, then this value capacitor is actually more than enough in order to fulfill the current requirement or the power requirement of the microcontroller. Okay. But if you find that you need to connect a higher value of capacitor, it's completely fine. You can also connect a higher value of capacitor without any problem. Okay. But you just have to make sure that this value should not be very small. Otherwise, again, the voltage will drop at this point. So for example, if there is a constant 5 volt on this line, okay, and there is a sudden current requirement by this microcontroller, and let's say that we have not connected capacitor here, then what will happen, as there is no fulfillment of current by any external source, because of that, it may happen that the voltage on the plus 5 volt line may drop. Okay, and because of this drop in voltage, it might happen that the controller may get reset, okay, which we don't want to happen, right? So that's the reason, in order to avoid this kind of situation, we need to connect enough value of capacitor in order to fulfill the power requirement of the microcontroller. Okay, so that's basically the purpose of 22 microfarad capacitor. And as I told, you can also connect a higher value of capacitor here. For example, 47 microfarad. You can also connect a 100 microfarad capacitor here. But as this particular capacitor is actually more than enough to fulfill the power requirement of microcontroller, so it's better we connect this value of capacitor. If we go for the higher value of capacitor, then unnecessarily the price of the capacitor will increase. Okay, so we are done with the 22 microfarad capacitor, and after that, now let's try to understand why there are 3.1 microfarad capacitors here. So these 3.1 microfarad capacitor we need to connect on the 3 VCC pins of this microcontroller. Okay, so there are 2 VCC pins and then there is 1 AVCC pin. So each 0.1 microfarad capacitor will be connected near each VCC pin. Okay, so this one will be connected near the VCC pins, and this one you can connect near the AVCC pin. Okay, it's completely fine whichever capacitor you connect. It's not like you should connect this one only. So you can connect any capacitor near each VCC pin. Okay, so you have to make sure that. Now, one thing that I want to tell you here is, it's not just about Atmega 328 microcontroller. No matter what controller you are working with, for example, if you are dealing with STM32 microcontroller, again in its datasheet, it will be given that you have to connect the 0.1 microfarad capacitor near each and every VCC pin. Okay, and this is not just in case of STM32 microcontroller. Even if you go for some other microcontroller, for example, Texas Instruments MSP 430 series microcontroller, then again you will find that you will have to connect this 0.1 microfarad capacitor near each and every VCC pin. Okay, so now the question comes, why we have to connect these 0.1 microfarad capacitor. So now let's try to understand that. There are actually lot of gates which are there inside the microcontroller. Okay, there will be multiple thousands of gates which are there inside the microcontroller, and they are switching in parallel. Okay, multiple times. And because of that switching, what could happen? This VCC line, or on this VCC line, you may see some kind of glitches. Okay, small glitches you may see. Okay, now in order to remove these glitches on the VCC line, and in order to keep the plus 5 volt pure plus 5 volt on this VCC line, we actually connect the 0.1 microfarad capacitor. Okay, and these glitches, you will observe these glitches on each and every AVCC or VCC pin of the microcontroller. And I'm not just talking about Atmega 328 microcontroller, I'm talking about any microcontroller with which you will deal. And that's the reason every datasheet's manufacturer or every controller's manufacturer, it's going to recommend to connect a 0.1 microfarad capacitor near the AVCC pin. And we have discussed the 0.1 microfarad capacitor in detail. We also saw the impedance versus frequency plot of the 0.1 microfarad capacitor, and we saw that this particular capacitor is actually good at filtering certain range of frequencies. Okay, and these glitches actually belongs to that range. That's the reason lots of manufacturer recommends to connect these values of capacitor, 0.1 microfarad values of capacitor, on the VCC or AVCC line. Okay, and some of the manufacturer, you will see in some of the manufacturer's data sheet, there will be 1 microfarad capacitors also. Okay, so in some cases you will have to connect 1 microfarad capacitor and 0.1 microfarad capacitor in combination on each and every VCC pin or some of the VCC pins. Okay, so I hope that this particular point is clear to you. And when we create the schematic, this is how basically we connect the capacitors on the VCC line. For example, if there are 10 VCC lines, then it does not mean you have to connect these 10 capacitors in the schematic near each and every VCC pins. Okay, we don't do that. This is how basically we connect the array of capacitors in this schematic. Okay, so I hope that this is now clear, and everything we discussed regarding these capacitors, I hope it's crystal clear. Okay, after that, now let's talk about the reset pin. So you can see here pin number 29 is basically reset pin, and PC, which is port C, and 6th pin. So port C 6th pin is actually the reset pin, and above reset you can see there is actually a bar. So this bar actually represents this particular pin is active low. So this pin is actually responsible for resetting the controller. Okay, and active low means what? When you connect this particular pin to the ground, because of that this controller will get reset. Okay, and in order to keep this controller out of reset state, you need to provide logic 1, or you need to connect this particular pin to the VCC. Okay, so with this information, now let's try to understand this circuitry. Actually, there is one section in our hardware which is user input switch. So even in that section, the same circuitry we have discussed, and there I have discussed the switch circuitry in lot much detail. So here I will not go in much detail. I will just give you a brief overview of how exactly this circuitry is working. Okay, and we will see the how we get this value and how we get this 0.1 microfarad capacitor's value when we will discuss the user input switch circuitry. Okay, so as we discussed that when we connect this particular pin to the ground, because of that this controller will get reset. Okay, so when you are developing a application, or when you are writing the code for a specific application, in that case you will find a need multiple time to reset the controller. Okay, so it's better to have a reset circuitry in your hardware, or maybe for example, if you have deployed your product in the field, then in some cases you may need to reset the controller. Okay, so there you actually need the reset switch in order to reset the controller. Okay, and that's the reason in most of the microcontroller based circuit you will find the reset circuitry. Okay, so this is basically the reset switch, and when you connect this switch, because of that this particular line, which is reset line, it will be connected to the ground. And when you press this switch, or when this particular point is connected to this point, because of that, this controller will be actually in reset state all the time. And when you release this switch, as a result, this controller will actually come out of reset state. Okay. Now, when you press this switch, because of that, there will be logic 0 here. Okay. As this particular point is connected to the ground. And when you release the switch, because of that, you can see this reset line is actually pulled to plus 5 volt with the help of this 10K resistor. So when this switch is open, because of that, there will be logic 1 here. Okay. So by default, there will be logic 1, and when we press the switch, there will be logic 0. And when we release the switch, there will be logic 1. And again, if we press the switch, there will be logic 0. And again, if we release the switch, there will be logic 1. Okay. So this is how basically the transitions will be on this reset pin. So when you press the switch, the controller will get reset. And when the switch is released, because of that, this particular pin will be connected to plus 5 volt with the help of this 10K resistor. And as this 10K resistor is pulling this particular pin to plus 5 volt, because of that, this resistor is actually going to, avoid the reset state. Okay. So this resistor is actually going to avoid the reset condition, which may happen, with the controller circuitry. So connecting this 10 kilo ohm resistor is actually very important. And how we got the value of this 10K resistor, I will discuss that in detail in the switch circuitry. And along with that, this particular capacitor, we are going to discuss about this capacitor in detail in switch circuitry. Okay. But this capacitor is actually responsible for removing all the noise which will be there on this particular pin. So this capacitor will decouple, or it's going to bypass that noise towards the ground. Okay. And along with that, if there is any kind of switching noise which is produced by this switch, again, that noise will be, bypassed by this particular capacitor towards the ground. Okay. So this particular capacitor is responsible for avoiding unnecessary reset of this microcontroller. Okay. Which may happen because of the noise which will be available on this reset line. Alright. So that was all about the VCC and AVCC circuitry, and along with that, this reset circuitry. And now we are just left with this particular capacitor which is connected on this reset line. And why I have connected this capacitor here on this reset line, about this I'm going to discuss in the upcoming videos. Okay. Because this is not the right time to discuss this capacitor. You will get the importance of this capacitor in the upcoming videos only. Okay. So I will not discuss it here. We will discuss in the upcoming videos. Okay. Alright. So that's what I wanted to tell in this video. I hope that every single thing that we discussed in this video is now clear to you. And if you still have any kind of doubt, then definitely you can reach to me and I will help you with that. Okay. Alright. So now I will see you in the next video, which is about understanding circuit of microcontroller part 2.